Okay, let's go ahead and get started. Welcome, everyone. Thank you for joining us today. My name is Martha Meyer, and I'll be acting as our moderator for today's webinar, Preparing for Pending NPDES Effluent Limits for PFAS in Michigan, Staying Ahead of Compliance. Next slide, please. So we're going to be covering a range of topics that should be considered in developing a successful NPDES program. We'll start with some of the background on the unique chemistry of PFAS. We're going to go into related policies and regulations that are going to affect compliance. And then, of course, drill down on some of the requirements that are specific to the state of Michigan. We'll discuss some of the challenges with lab analysis, and then we're going to finish up with a discussion of water treatment options and considerations. So we have a great group of experienced speakers today. Some have well over 15 years of experience working with PFAS issues, which is a little bit unusual. So I'll quickly introduce everyone, and then we'll go ahead and get started. So we will hear today from Rock Vitale, Rick Scheuer, Mike Allen, Nick Backman, Sean Gilday, all from Montrose companies. And we'll also hear from Fred Andes and Erica Powers, who are joining us from Barnes and Thornburg to offer a legal perspective. We'll be taking questions at the end of the conversation today, so please go ahead. There should be a Q&A button at the top of your screen, and you can go ahead and type any questions you have during the webinar. We'll get to those at the end. So next slide, please. And I will go ahead and hand it over to Rock for everybody's favorite subject, chemistry. Thanks, Rock.
Good day, everyone. If we talk about that bad four-letter word PFAS, it's all about the chemistry. Next slide, please. So what are PFAS? They are all man-made synthetic compounds. So there's no such thing as naturally occurring organic fluorine compounds. PFAS is a general name for a large family of compounds. By some definitions, 8,000 to 15,000. The Europeans have proposed a definition of over 7 million of them, and that is anything with a CF2 or CF3 moiety. PFOA and PFAS, collectively C8, have historically been the most regulated compounds, but more and more are coming into play, as you'll note in the MCLs. We have PFNA and PFDS. These were manufactured in the 1930s and were commercialized in the 1940s. So they've been around for about over 80 years. So not quite the emerging contaminants of concern, if you think about it. PFOA and PFAS are not currently produced in the United States. And folks are scrambling to find replacement chemistries, specifically for AFFF foams. But the thing with finding replacement chemistries is we really need to do our homework on the toxicity of those compounds. We don't want to replace one thing with something that's potentially just as bad, if not worse. Next slide, please. So again, definitions. If you think about PFAS, back in 2011, back in the Stone Age, there was only 268 of them. And they excluded fluoropolymers. Fluoropolymers are really, really important when we talk about PFAS because they are included in the definition, and yet none of the analytical methods really include fluoropolymers to any significant extent. So Buck back in 2011 specifically excluded them. As time went on, we go from Buck again in 2021 to 56. OECD in 2018, we had almost 5,000, currently proposed over 7 million. The US EPA has taken a really unusual approach by saying it depends what the program is, what the region is. So as you'll see, without a clear definition, it is difficult to design toxicity studies on classes and subclasses. Without a clear definition, it is really hard to develop appropriate analytical methods that capture everything of interest. And definitions changing by jurisdiction, a la EPA or regulation, is like trying to comply with moving goalposts. Next slide, please. So We talk about PFAS in environmental samples and everything from the air we breathe, the water we drink, soils, sediment, etc. But more and more, it's becoming of significant interest in the consumer products that we buy every day. Um, I am the co-chair of the ASTM group F15.81, which is consumer PFAS in consumer products, and we are just reballoting our first standard actually within the next few days. As you can see, 46 of the states in the continental United States have either proposed or pending regulations as it relates to PFAS materials being intentionally added in consumer products. Next slide, please. So this concept of intentionally added, okay? Many of the things over these 84-year period since they've been commercialized, they're in products including stain repellents, non-stick products, polishes, waxes, paints, cleaning products. It's used extensively in chrome plating, plastics extrusion, and other manufacturing applications. And as some of you may know or have been following, the high-density polyethylene container, fluorinated containers with EPA versus enhanced. This is a really, really big deal as it relates to consumer products. It's also used in oil and gas extractions, processing, and transportation. And of course, the major one is firefighting foams, okay? It's a major source of groundwater contamination at airports and military bases where firefighting training has occurred. So, but besides the intentionally added, we have inadvertently created, a la fluorinating the high-density polyethylene containers, or simply, as it relates to the consumer products or even TSCA for that matter, simple PFAS impurities or contaminants found in the handling of raw materials. Next slide, please. And now I'm going to hand it over to Fred and Erica to talk about US EPA and the states setting the stage.
Thanks very much, Rock. Again, my name is Erica Powers. I'm a Clean Water Act lawyer at Barnes & Thornburg, and I'm here to talk to you a little bit about the next slide, which is a kind of US EPA action on NPDES permits. So in late 2022, not quite 2 years ago, EPA issued a memo on the inclusion of PFAS conditions in NPDES permits. The goal of this memo was to leverage the NPDES program to decrease PFAS discharges to the nation's waters, and also to obtain comprehensive information on quantities and sources of PFAS discharges around the country. So for POTWs, or publicly owned treatment works, EPA wants their NPDES permits to now include quarterly testing of influent, effluent, and biosolids. And for some industrial categories of direct dischargers, they also want to include quarterly effluent testing. EPA identified 12 primary suspect industry categories and 4 ancillary categories. The primary categories are organic chemicals, OCPSF, metal finishing, electroplating, electric and electronic components manufacturing, landfills, pulp, paper, and paperboard manufacturing, leather tanning and finishing, plastics molding and forming, textile mills, paint formulating, and of course airports. The ancillary industries that EPA is looking at and wants POTWs to look at as well are centralized waste treatment or CWT facilities, also remediation sites, any chemical manufacturing not covered by the organic chemicals category, and also military bases, particularly those where AFFF firefighting foam has been used. So indirect industrial dischargers to POTWs that are in those categories or who are found to be discharging PFAS are to be dealt with in the pretreatment program. So if you're an indirect discharger, you might see from your local POTW an information request, surveys, sampling requests to try and identify the presence of PFAS in your effluent and also to quantify it. The monitoring is recommended to be done with the draft method 1633 for wastewater that tests for 40 different PFAS compounds. And also the draft method 1621, which detects organic fluorine. This one is a little bit maybe dangerous for dischargers because it identifies anything containing fluorine, not necessarily PFAS. But we're going to talk a little bit more about method issues later. But using one of these methods, if those compounds are found, then EPA says limits should be considered. They're primarily focused on best management practices or non-numeric pollutant minimization efforts. Those can include product substitution, minimization procedures for accidental discharge containment, and also equipment contamination or replacement. So it's not necessarily enough to switch to a PFAS-free product if you were historically using PFAS products, because legacy contamination can live in your pipes and other equipment. So decontamination and replacement of old pipes and equipment can be important. However, in addition to those kind of source control efforts, EPA indicates that numeric limits should be considered, particularly where your state has adopted numeric water quality standards or where EPA has adopted PFAS standards as part of their technology-based effluent limits or effluent limitations guidelines. Where no such federal guidelines exist, EPA suggests that permit writers use their best professional judgment to determine whether a numeric limit is appropriate on a technology basis. Best management practices for AFFF for firefighting activities include limiting their use in training activities such that they're only used for firefighting, and also appropriate containment and disposal if there is a fire that AFFF has to be used on. So that's the kind of summary of EPA action on permits, and I'm going to turn it over to Fred to talk about how the states are responding.
Sure, thank you. So states have taken a variety of different approaches to addressing PFAS in permits, and when we're talking permits, we're talking particularly direct discharge permits, NPDES permits, which in Michigan are issued by the Department of Environment, Great Lakes, and Energy, or EGLE, as we call it. Michigan has really been one of the leaders on this issue, particularly because it's been faced with some PFAS challenges earlier than some other states have. Some states really haven't addressed PFAS in water permits at all yet. Some of them are really waiting for clear guidance and requirements from EPA, from US EPA. The methods haven't been finally approved yet. Some states feel like they shouldn't move ahead until the methods have been approved. So in some states, we don't know yet where things are heading. Some states have acted outside of permits, instead issuing administrative orders and information requests to, like New Jersey, for example, to gather information from dischargers to get a better sense of what those plants are discharging, and also particularly for municipalities, what they're receiving from the industrial users. Some states, for a variety of reasons, have moved more actively, including Michigan, but also Illinois, Missouri, in some cases due to public or political pressure, because although there is that EPA guidance that Erica talked about, it doesn't appear yet that US EPA is sort of actively mandating what states have to do in terms of putting PFAS conditions in the permits. They've recommended those various things that Erica talked about, but they haven't really pushed states saying, well, unless you do this, we're going to have a problem or we're going to object to permits. In our discussions and meetings with US EPA people, my sense is that they understand that this is a new thing that hasn't really been addressed in NPDES permits yet, and that they need to be somewhat flexible in terms of what they're expecting to see in states. It is sort of as an initial matter, the EPA does want to see states at least require monitoring, particularly using 1633 of for industrial facilities discharges. There are effluents. For municipalities, clearly influent, effluent, and biosolids. Most states that have acted so far have not tended to put numeric limits in. Now, most states don't have numeric water quality standards yet for PFAS. Michigan does for a couple of PFAS. And in fact, what Michigan has been talking about, and there are compliance strategies that Michigan has issued, one for industrial and one for municipal. And I would say sort of the general approach is moving toward numeric limits. And that some discharge permits will include numeric limits. For example, Michigan's water quality standards for PFOS are, depending on whether you're on a source of drinking water, 11 or 12 parts per trillion. And what Michigan has been doing is saying, either through administrative orders or through permits, telling dischargers, particularly municipal dischargers, that, hey, we want you to be sampling. We want you to be looking at what issues want you to figure out what your sources are, start looking at means to address them, work with your industrial users to figure out if there are things they can do to reduce their PFAS loadings. For example, electroplater, if they're using a fume suppressant that has PFAS, can they move to one that doesn't have PFAS? That's actually been a pretty successful program in Michigan. To reduce loadings from POTWs in that way. So they definitely want that to happen, and they want people doing those types of actions to identify sources, assess control options, and then continue reporting on how that's working. In some cases, that's going to include, all right, you've got a limit of 11 or 12 parts per trillion. What are you doing to get there? And if you're not there, we want to know what you are going to do to get there. So it's a process of sort of understanding the issue, doing monitoring, looking at options. But some sources are definitely going to get limits, particularly if you're discharging to a source of drinking water. It's more likely you're ultimately going to get permit limits. Now, one thing to keep in mind on the permit limit issue is, Michigan only has a couple of water quality standards for PFAS. Other states don't have any yet. But EPA just put out some aquatic criteria for PFAS, which in most cases are going to be pretty high and won't pose issues. But they are about to put out draft human health criteria for PFAS, which are likely going to be much lower than what Michigan has already adopted. We're talking about parts per quadrillion. So those numbers will pose a lot of issues for a lot of different types of facilities. And if those become permit limits that nobody can meet, we're going to be talking probably about variances. And actually, Michigan already did that on mercury, adopted a statewide variance program. So that's something that's a next step that's coming. Is one issue is, all right, you've got some numbers right now in state rules. What are you doing to meet them? But much lower numbers are coming. And that's something that we're already starting to plan with our client facilities. It's important to keep in mind that environmental justice issues can be raised, which could result in even lower limits and more requirements in permits. It's still very uncertain in terms of what US EPA and the states will do on that issue, but it's always something we keep in mind. There will be more discussion later in the presentation about Michigan specific issues, but I will say to conclude that, as I said before, Michigan's been a leader on this issue. There are actually some really good lessons learned from what Michigan has been doing so far in dealing with water dischargers in terms of things that work, things that don't. But it's also important to take a very plant-specific approach to this. State has seemed pretty understanding of that in terms of really wanting to see progress in identifying and reducing PFAS sources, but understanding that that's going to look different in every situation. Thank you.
All right. Hi, this is Sean Gilday. Next slide, please. So speaking of widespread contamination from firefighting foam, I'm starting with a picture of my brother and I from the early 1980s. The local fire department used to fill the neighborhood field with firefighting foam, and us kids would run around and play in it. I'm not certain as to whether this was AFFF or PFAS firefighting foam, but I like to show this because it serves as a reminder about PFAS usage historically. And also, it really highlights a significant shift in our understanding and regulation of these substances today. Next slide. So today, we are seeing new PFAS regulations promulgated under almost every major environmental program. So that includes RCRA, the solid waste regulations, IPCRA, where we have toxic release reporting obligations, TSCA, regulations that govern manufacture, importation, and use of certain chemicals, Safe Drinking Water Act, which Fred was alluding to in the previous slide, which is where we see the chemical concentrations in drinking water sources being regulated. CERCLA, also referred to as Superfund, regulating previously disposed and abandoned chemicals and the cleanup thereof. And of course, the Clean Water Act and its primary compliance tool, the NPDES permit, which is what we're discussing today. And these are all, so these are federal regulations. And these are in addition to what you heard from Fred about potential EJ concerns and state-specific regulations. Lastly, and important to note, if you see on this slide, the date of each of these new rules, all pretty much within about the past 12 months or so. I believe we're going to continue to see this pace, regardless of what happens next Tuesday. Next slide, please. So as we review the various environmental regulatory laws, it's always important to understand the terminology. I'm providing this slide here as a bit of a lexicon to help navigate each environmental law. Each environmental law does have its own unique scope, and as you heard from Rock, a different definition of PFAS. So PFAS is referred to differently depending on which framework you're operating under. Next slide. So more specifically, and kind of focused on our topic today, the proposed regulations under RCRA are considering adding 9 different PFAS compounds to the hazardous constituents list, not the hazardous waste list, but constituents list. And they're also suggesting to change the cleanup criteria at hazardous waste TSDF facilities to formally include hazardous constituents. This is perhaps a first step or the groundwork to possibly getting PFAS into a hazardous waste definition. Under CERCLA, PFOA and PFOS, the ones that Rock had mentioned are historically been the most regulated, are on the hazardous substances list and therefore regulated under CERCLA. So if they are placed or released into the environment, that's where you'll see the interaction with that regulation. And then under IPCRA, several more PFAS have been added to the TRI reporting applicability list this year. More have been added each year since 2021, the first reporting year. And PFAS has also been added as a chemical of special concern. And through that change, EPA also removed several exemptions to the chemicals of special concern. So they've removed the de minimis exemption for supplier notifications. And this broadly affects all other chemicals of special concern too under IPCRA and TRI reporting. And then lastly, under TSCA, EPA has announced a massive data request, essentially asking anyone who has manufactured any PFAS over a 12-year period from 2011 to 2022 to report. And somewhat unique for TSCA is that they've eliminated most typical TSCA reporting exemptions. And the definition of manufacturing can include what you heard Rock talk about in his first couple slides, inadvertent byproduct creation. And this is in addition to importation. Next slide. So even though we are discussing obligations under NPDES and Clean Water Act for PFAS, be aware that these other regulations are out there. And if you're subject to one, you're very likely subject to several others. For example, RCRA and CERCLA possibly changing your disposal options and costs. Or if you're incinerating wastewater treatment plant sludges, those could all be affected by these changes in those regulations. And then under IPCRA and TSCA, again, if maybe you're not intentionally using PFAS or intentionally manufacturing PFAS, but if you're coincidentally manufacturing, inadvertently manufacturing, or chemically transforming PFAS in your wastewater treatment system, you could be considered to be manufacturing PFAS and subject to somewhat substantial reporting obligations under these two regulations. Next slide.
Good morning, everybody. Rick Scheuer. Next slide, please. So the Michigan Department of Environment, Great Lakes, and Energy, EGLE, is one of the most progressive states regulating PFAS. The MPART PFAS Geographic Information System was established in 2017 to address the threat of PFAS contamination in Michigan, protect public health, and ensure the safety of Michigan's land, air, and water, while facilitating interagency coordination, increasing transparency, and requiring clear standards to ensure accountability. MPART is charged with providing recommendations to department directors and coordinates efforts between them. In March of 2019, EGLE began the process of rule promulgation. In April of 2019, a science advisory work group was established comprised of national PFAS experts in toxicology, epidemiology, and remediation with EGLE and the Michigan Department of Health and Human Services, in which they prepared a report recommending health-based values for PFAS in drinking water. The Working Group June 2019 report recommended health-based standards for 7 PFAS, and the rule became effective August 3rd of 2020. PFAS, as of March of 2021, EGLE defined a PFAS site as a property where EGLE has a valid groundwater monitoring sample result that exceeds one or more of Michigan's 7 PFAS groundwater cleanup criteria. And based on data, EGLE has determined the property is the location of the source of PFAS contamination. EGLE defined an area of interest as being investigated due to the potential for PFAS contamination to be affecting residential wells, for which a source has not been determined. Areas of interest are created based on data showing the potential for human exposure, which may also generate significant public interest. Next slide, please. So this slide shows the 7 PFAS compounds that Michigan has established MCLs for under drinking water. So the column 1, the far left, is the 7 PFAS compounds. The second column are EPA's MCLs, and note that there's no PFHXA or Gen X for EPA MCLs. The third column is EGLE's drinking water MCLs. The 4 yellow highlighted MCLs are above the current EPA MCL and will most likely be lowered to EPA's MCLs in 2025. The EGLE PFAS MCLs that are lower than the EPA MCLs are anticipated not to change. The fourth column are the NPDES discharge limits into surface waters not used as a drinking water source. And the last column is the NPDES discharge limits into surface waters used as drinking water sources. And note again, there's no MCL for PFHXA or Gen X. Next slide, please. In April of 2018, EGLE started PFAS sampling for public water supplies. This was completed in 2 phases. Phase 1 targeted community water supply, schools, and daycare providers that had their own source well, and the Michigan Head Start program that uses surface water sources. Phase 2 focused on non-community public water supplies. And between 2019 and 2020, approximately 80 schools were tested, and if the total PFAS was above 10 parts per trillion, they were placed on a quarterly sampling program. The initial compliance monitoring program ran from August of 2020 to February 2021. Water sources where PFAS was reported were placed on a quarterly sampling program, which started in January 2021. A water source was determined to be out of compliance when a revolving quarterly average was above any PFAS MCL. When this occurs, public notification from the water provider is required within 30 days. Next slide, please. Eagle issues NPDES permits for discharges to lakes, rivers, streams, and groundwater. Eagle took a very proactive approach starting in 2017 by sampling wastewater treatment plants, airports, landfills, and industrial facilities. The Industrial Pretreatment Program is a federal mandated program of the Clean Water Act. Eagle uses the IPP to identify suspected potential dischargers to sample and monitor for PFAS. IPPs also allows wastewater treatment plants to require upstream dischargers to the plant to investigate their discharges for PFAS. This year, there are 4 additional questions that were added to the Enviro application for PFAS. The first question is this facility known to have PFOS and PFOA present in wastewater discharge in the surface water state? Second question is this facility a landfill or solid waste with a discharge of leachate? The third is, do any of the following activities at the facility discharge wastewater? And the list is fairly long, but includes metal finishing, pulp and paper production, chrome plating or chromate conversion, car washing, apply coating, remediation of contaminated site, commercial and industrial laundry, leather or high tanning finishing operations, applying a stained dirt, water, or fire-resistant coating and or protectant, manufacture, formulation, or mixed paints and pigments, carpet and or upholstery cleaning, carpet, rug, and textile manufacturing, and or centralized waste treaters treat for recovery, metal-bearing oil or organic waste, wastewater use material received from off-site and are regulated under 40 CFR Part 437. And lastly, the fourth question, has aqueous film forming foam ever been used at the facility for training or testing, or to respond to a fire emergency, or ever been stored at the facility? Now remember the previous NPDES permits discharge limits for either drinking water or non-drinking water surface sources. Those are not necessarily your effluent NPDES permit. Since every facility is different, individual NPDES permits may vary also. For PFOS, which is a bioaccumulative, the standard will be either 11 or 12 part per trillion. However, for the other 4 PFAS, the Eagle permit processor, together with aquatic biologists and stream modelers, decides which parameters require limits. Sometimes a limit is not necessary, but further monitoring is required to gain more information about the quality of the facility's effluent. The Water Resources Division must derive an approximate limit for each parameter of concern. When a limit is derived, 2 factors must be taken into account: water quality and available treatment technology. Federal regulations specify industry-specific standards which are achievable using available treatment technology. Using the Code of Federal Regulations, the permit processor derives treatment technology based on effluent limits. The permit processor must then compare the water quality-based effluent limit to the treatment technology-based effluent limit for each parameter. The more stringent limit is used as the effluent limit in NPDES permit. Next slide, please. Effective this year on January 1st, 2024, Eagle's interim strategy for land application of biosolids became effective, requiring sampling and reporting of biosolids. Eagle has one of the select few states with biosolid standards for PFOA and PFOS. There are 4 categories of standards. Over 100 part per billion for PFOA or PFOS is restricted and cannot be land farmed. Between 20 part per billion and 100 part per billion, they categorize that as elevated restricted land farming, where the 1.5 tons per acre of application can be applied, but with sampling every 30 days. If you have less than 20 part per billion, you're under a report only category, which requires sampling and reporting through the Michigan Enviro portal for approval and notification to property owners and the farmer. And the last one is an exceptional quality. And this is if you have less than 20 part per billion total for PFOA and PFOS, where you have quarterly sampling and reporting and sampling of the source's effluent. You need approvals for reporting through the Michigan Enviro portal for approval and notification to the property owner and the farmer. And that concludes mine, and I'm going to turn it over to my colleague, Mike Allen.
Thanks, Rick. Next slide. So my colleagues have done a good job outlining a lot of the regulatory landscape for us. And now we'll talk a little bit about what you need to consider as you engage with a laboratory to get you some analytical data to find out where your levels are. One of the first things to consider is your timing. So what is the timeline that you have available to work within, and then talk to the laboratory about what their turnaround time is for the specific tests. And also, one thing that might be important is to ask them about their on-time delivery percentage. Another aspect is there's going to be times where your timelines get compressed and you're going to need fast turnaround. So it would be important to ask, what's your availability for fast turn, and what are those turnaround times? Another good thing to know is, are you going to deal with a single point of contact, or are you going to have to go through multiple folks to get answers about the analytical testing? Ideally, it's a single point of contact. That way you can work through that person to get all the sample logistics for shipping and kits and receiving and your analytical testing, and then also on your reporting side. Michigan currently has a program for accrediting for drinking water. They do not have an accreditation program at this point for method 1633, for example. But as that comes along, I'm sure labs will jump on board and chase that. So just for everyone's information, what you have to do then is default to a national accreditation program. So like the DOD or a NELAC accreditation, TNI accreditation. The depth of experience with analytical methods is important. Method 1633 and 1621 can be challenging. Some of the things that you have to deal with are a wide variety in sample matrices, a wide variety in the type of particulates that might be within a sample, or just issues in general that could prevent from completing that sample. So having that experience and understanding is important, something to consider there. State-of-the-art equipment and also redundancy. That's important because as we've heard about the MCLs being lowered and lowered and potentially even pushing down into part per quadrillion levels, having up-to-date equipment that can achieve the sensitivity required to meet these needs is important, and also making sure that you've got redundancy. So if something happens to a specific piece of equipment, there's a backup for it. Ease of access to analytical subject matter experts is that's also a critical thing. All the good labs out there that you would work with potentially are going to have subject matter experts, but I would encourage you to press to see what the availability of those people are and how quickly you can get a hold of them when you need them. Availability of support technologies and methodologies. We'll talk a little bit about an example where this is important, but these are things like total oxidizable precursor assay, ability to analyze some non-traditional ultra short chain PFAS, and then just having an extensive expanded PFAS list, even beyond the 40 compounds in 1633. And then the last thing is important is to make sure that the reporting format that you're going to get is going to meet your needs. A lot of folks are going to need a specific EDD, or electronic data deliverable. And so having that format is something that making sure up front is going to make it go smoother on the back end. Next slide. So the two primary tools that are used from an analytical perspective are EPA method 1633. This is a targeted methodology that's used to quantify PFAS. It is highly selective and highly specific for the 40 targets that we're monitoring for there. And then method 1621 it's a non-specific method. In other words, it cannot tell if you've got a C8 or a C6 PFAS. It can only tell you that there is an organic fluoride compound present and give you the total concentration of those. And then one other thing I'll say about method 1621, its report limits are a lot higher, for example, in the 1 to 5 part per billion versus a target analysis, which is in the low part per trillion typically. All right, next slide. So one of the things that industry has been able to do is come up with some replacement compounds. These were brought about to try to overcome some of the toxicological issues and some of the environmental concerns. And I think they were done with good intent. However, there's a saying about good intentions. Some of these compounds can actually cause downstream problems. A lot of these precursors, if they're not already in a terminal state, they can further oxidize and become potential problematic PFAS for you. So next slide. So this is a perfect example of that. If you start with 82FTOH, which I'll point out is not on our targeted list for 1633, so that is something just to be aware of. It's typically the technique that you would typically use for 82FTOH would be more GCMS oriented, whereas 1633 is LCMS oriented technology. But this compound is one of the precursor compounds, and it can go through either a natural biodegradation or if your process, for example, if you're intaking 82FTOH and your process involves some oxidative steps, you can be unknowing to you or inadvertently forming some of these more concerning PFAS like PFOA, that's a big one, and PFHXA. Those are both on the MCL list. So just something to be aware of. Next slide. And so what we've been talking about are, what you're seeing here is a list of available methods that can be utilized to analyze for PFAS. We pretty much just focused on the 4 in the box here, in the red boxes. So we talked about 1633 and it's being a targeted analytical methodology. We talked about ultra short chains. One thing I'll also say about the ultra short chains, they're not specifically on anybody's NPDES permitting that we've seen at this point, but we have seen where the EPA has set some regional screening levels for some of these, specifically PFPRA, which is C3, and HQ115 or TFSI. It's another short chain PFAS. We talked about the AOF CIC methodology, EPA 1621. It's a non-targeted, gives you a total assessment of organic fluorine. And then the TOPA we talked about as well. And that's a good investigatory analytical technique that can help you to understand if you have things that are coming into your facility that may eventually form downstream PFAS that are of concern. Next slide. So that's the end of my talk, and I'm going to turn it over to my colleague, Nick.
Thank you, Mike. Good morning, everybody. We appreciate you attending. I'm going to bring up the rear here and close up our talking points today by discussing some treatment technologies. If you find yourself in a situation where you need to consider treating for PFAS, we can help you meet your discharge effluent goals below those regulations. Next slide, please. There's going to be a few parameters that will help determine the most cost-effective and operably efficient technology for PFAS treatment. Those parameters are, number one, the application. Industrial, as an example, whether it be the source or the discharge, we can help you meet your discharge parameters. Wastewater, we can help treat at the point source. Also wastewater treatment plants, POTWs. As mentioned earlier, landfill leachate is a significant contributor. Of course, groundwater, stormwater, and drinking water. So knowing your application, your flow rate, and your discharge goals we can help you design the best treatment program. So if you want to go to the next slide, I'm going to highlight a couple of PFAS treatment options. At ECT2, we offer what we refer to as agnostic treatment solutions. So we are not positioned to sell one technology. Instead, any and all combinations or variations in the right series of flow so that your capital and operational expenses are considered over time. Some of the treatment technologies include, and we could talk for a long time about each of these. I'm going to touch on them briefly. Number one would be granular activated carbon, often referred to as GAC. This is typically recognized as the best available technology in the state. And in large part, Ann Arbor, for example, put in carbon in 1999 to remove TOC from the river for their drinking water. So what they saw is carbon was working pretty efficiently on removing PFAS. It's inexpensive and it works to a point. We've got single-use ion exchange, which performs adsorption similarly to carbon, but it also, of course, performs ion exchange here, where you could consider it like a lock and key. Once it's in place, it tends to hold on to the resin. The resin also has higher preferential selectivity for PFAS with selective functional groups and requires a lower contact time. So you've got smaller media vessels, less change outs. One note of ion exchange is it can be affected by co-contamination. So there are situations where we need to consider pre-treatment for things like iron, manganese, solids, oxidation, such as like free chlorine. Regeneratable ion exchange. This is a patented ECT2 process. And if you look, you're going to see that we have the 3 largest remediation ion exchange systems in the world. Those are designed to treat up to 10,000 gallons per minute. This was essential here for our customer because not only did we have large flow rates, but we had very high concentrations of PFAS. And as mentioned and alluded to earlier, in this instance, we had a large concentration of difficult to remove PFAS, in this instance, PFBA. With a single use option, we were breaking through at our target discharge goal around 100 bed volumes. So to put that into perspective, on a 10,000 GPM flow rate, you'd be changing out 39 8-foot diameter vessels with about 300 cubic feet of ion exchange media per vessel almost every other day. We provided a regeneratable process, which allows them to reuse the resin over time. And we've seen extremely efficient results, not only in the removal, but in the regeneration process. If you look down at the bottom there, the technologies, you will see foam fractionation. This is a physiochemical separation process where essentially we're adding air to an influent tank to your PFAS impacted water. The PFAS by nature want to create a physical foam. So adding the air helps create that foam, and the surface tension makes the foam float. We process the foam into a foamate and then concentrate that further into a liquid. So your effluent stream is going to be considerably less impacted PFAS as a total. From there, we've got a number of options. Further concentration, we can use a technique we refer to as superloading, again, utilizing ion exchange and carbon. And we also pair very nicely with various destruction technologies. Lastly, I would like to briefly touch on our nanosorb technology, which essentially is an enmeshment into the biological flocculation process of waste activated sludge. For example, wastewater treatment plants, POTWs, large flow rates. What we're doing is adding a product, nanosorb, and that helps concentrate the PFAS onto the biosolids, which then generates a discharge effluent stream that's going to meet your permit requirements. The nice thing here is we can retrofit the nanosorb technology into existing configurations such as membrane bioreactors. So this really helps minimize your capital costs and operating costs over time in comparison to using GAC, for example, and doing multiple change outs. In short, we're available to support any of your potential needs. We like to start from the ground up, help develop, design the best treatment program. We can build it, install it, start it up, operate it, and support. And as it references there, we've treated over 10 billion gallons of PFAS impacted water today. So we would greatly appreciate any opportunity to support those PFAS removal needs. I'll be available for questions on any of these technologies afterwards, as well as during the question and answer session, which we will begin now. Thank you.
Thank you to all of our speakers. There's some very useful information there. And we've just got a couple of short minutes to answer some of the questions that have come in and that were submitted with the registrations. So let me start with, is there funding available to conduct investigations for PFAS sources and or remediations? And Rick, do you want to go ahead and take that one?
Sure, I will take that. And there is a little bit of funding through the infrastructure bill that came through. However, it is very small. The annual budget is about $800,000 a year and basically only provides some of the EJ and smaller facilities with some analytical support. It doesn't support remediation efforts or on a larger scale, unfortunately, at the present moment.
And while I have you, Rick, could I just ask, are there any regulated timeframes for identifying upstream sources and or compliance?
Right now, the Eagle has been very flexible with working with the POTW or the upstream potential PFAS sources. So they haven't necessarily gone to a stringent time frame. They are looking for, a plan and action to move forward, and they are encouraging them and working. And so far, they don't generally end up having to issue administrative orders with specific time frames.
Thank you, Rick. Fred, maybe you could take this one. How do PFAS limits affect the individual site NPDES permit? So I'm assuming that is referring to the state standard limits.
Well, the excuse me, sort of consistent with what was just said. The emphasis so far has been less on putting limits in permits, although that can happen, and more with putting in reporting requirements, doing the testing, reporting the results to the state, and starting to show, and particularly for municipalities, what are you doing to look at your industrial users, to identify other sources? What are you doing to try to reduce those? There are some situations in which permit limits will be put in, such as the 11 or 12 parts per trillion we talked about before for PFOS. And then, but again, the state's approach on that seems to be, all right, we're giving you that number. We're not expecting you to meet it right away. We want to see progress. We want to see that you're taking actions to get there. Ultimately, they want you to get there, but we haven't seen anybody getting there yet. But it's more about progress toward that goal. As I said earlier, there's a possibility going forward that the numbers are going to go down significantly and actually go to numbers that we probably can't meet for anybody. And we're going to have to think about ways to deal with that. But the trend is definitely toward permit limits, and you having to meet those for your discharge, whether industrial direct discharge or for municipalities, and ultimately getting limits in the permit for, starting with like PFOS, PFOA, and a few others, but ultimately probably broader than that is getting limits in the permits and having to deal with that. It's a compliance issue like for other situations, including, all right, do you need a compliance schedule because you can't meet it right away? Can you not meet it at all and you need a variance? So all of those mechanisms that we use for dealing with permit limits will come into play. That's going to happen over time. Now, there are not very many that have limits, but that's going to be happening going forward.
Thank you, Fred. I think we have time for one more question. Let's see. Will my NPDES permit regulate how I manage my biosolids? I know we touched on biosolids. Will that be directly in the permit? Maybe Fred or Erica could take that. Thanks.
I can talk a little bit about that. It may be. If you're a PO2W, you may find that your state has regulations about how you can dispose of biosolids. That might be incorporated into your permit. The EPA guidance that I talked about wants PO2Ws to start quarterly sampling of biosolids to at least gather information on PFAS content. And then, assuming that the information will feed into later iterations of your permit and may regulate what you can do with it.
Yeah, I would just add that the state of Michigan's guidelines that were discussed earlier are really a leading example of a state moving ahead while EPA has not developed biosolid standards. Other states now are starting to follow Michigan and in fact adopt Michigan's numbers. The EPA standards, EPA does plan to develop biosolids standards under 40 CFR 5 under the Clean Water Act, basically, under their program for developing water sludge management standards. But they're saying it's going to be probably 5 years before there are new EPA numbers. So states are looking at what do they do in the meantime and doing things like what Michigan's doing, which is saying it's not necessarily in your permit, but these are our guidelines. And if the levels that come in the biosolids are above certain levels, we either can't land apply them or can only land apply them to a certain extent. So that's what we expect to be in place until EPA develops actual sludge management standards, which, as I said, probably won't be for a few years.
Thank you very much. And we've run out of time, but please, we will be sending out any additional questions that we got. We will be emailing replies to those. If you have any additional questions, please go ahead and contact us. And thank you very much for attending. We will be sending out a copy of the slides, I think, fairly shortly today. And once again, thanks to all our speakers and thanks for all of our attendees today. Really appreciate it.
Thank you.
Thank you, everybody.
Thank you.